Okay, let's finish out chapter 1. This is our last section and the last video from 1.6. So the first video from 1.6, we introduced the idea of inequalities. We have 4 different types of inequalities. We have less than, greater than, less than or equal to, and greater than or equal to. In this last page of notes, we are going to look at compound inequalities, and we have 2 different types. So kind of like compound sentences. You've probably heard that word before, and you know that it means you have 2 sentences that are joined by some kind of a connector word. And same thing here. So the first compound inequality that we're going to talk about is a conjunction. And this is a compound inequality, so it's 2 or more inequalities that are joined with the word and all of the solutions to a conjunction make both inequalities true. So let's look at an example. Solve 3 is less than x minus 5 and x minus 3 is less than 7. That means our solutions are going to be all the values of x that make both of those inequalities true. So whenever you see that word and, you need to think both. So the way that you solve this is you solve the 2 separately. So I'm going to solve 3 is less than x minus 5 to find out what values of x make that true. And then completely separate, I'm going to solve x minus 3 is less than 7 to find what values of x make that true. And then we are only going to include the points that make both of those true. So on this first one, we want to isolate the x. That means we need to get it by itself. We can add 5 to both sides. And I get 8 is less than x. Now, traditionally, we list the x first. So if 8 is less than x, x has to be greater than 8. So for the first half of this compound inequality, we get that x is greater than 8. Now let's look at the other side. X minus 3 is less than 7. We solve this just like we would if it was an equation. We would add 3 to each side. And we get x is less than 7 plus 3, which is 10. So let's just take a look on a number line. I think that's a good way to see what numbers make both true. So I'm just going to mark off 0. And I'm going to say 8 is about right there, and 10 is just a little bit higher right up here. So let's start. I'm going to change colors on my pen to make this a little easier to see. I'll do red. So I'm going to do x is greater than 8 in red. So notice it's just greater than, it's not greater than or equal to, so that would be an open circle going out to the right. So that is x is greater than 8. I'm going to change colors again. I'll do green. Green for the x is less than 10. So again, it's not less than or equal to, it's just less than. So I'm going to circle the 10 and go to the left because that's my less than side. So we want the numbers that make both true. So that's the overlap. So that's the numbers that are both red and green. And I'm going to switch back to blue to put my final answer in blue. So right here in the middle, we have the numbers that are in between 8 and 10. Those are the numbers that we want. So I'm going to put an open circle on the 8, an open circle on the 10, and we just want these numbers in between. So even though I have some numbers marked with red and green, those are not my final answer. My final answer is this part right here that is in blue. It's that overlap. So anytime you have the word and, you're looking for where your 2 inequalities overlap, and that's these points right here. So we can write this answer as x is greater than 8 and x is less than 10. But there is a shorthand for whenever you have the area that's in between 2 points. This is the only time you can use this shorthand. Whenever you are filling in between 2 points, you can list the first point. So you're always going to go left to right. So if we go left to right, we have 8 and then a less than x, and then another less than 10. So the way this reads is 8 is less than x is less than 10, or you can also read that as x is between 8 and 10. And here I just notated that. I'm not sure why I wrote it out with different numbers, but just to describe that shorthand, 3 less than x less than 5 is shorthand for, and I'm going to type this out, x is between 3 and 5. So anytime you see this where you have the x in between two numbers, it means that x is in between those. Now, whenever you're writing it, like we got to the end of this problem and we said we could write it that way. A couple things you need to keep in mind. You can only write it that way if the arrows are going the same direction. So I turned around the x is greater than 8 and wrote it as 8 is less than x for this first half. Let me get rid of that. Why is that? So once I turn that around to write the 8 first, it's 8 is less than 8. Notice the arrows go the same direction. 8 is less than 8, and then x is less than 10. So when I line that up with the 8 first and then the 10 at the end, the arrows go the same direction, so that's very important. The inequalities go the same direction. And if you cover up the center, which means when you cover up the x, it's true. So if we covered up the x here in the middle, we'd have 8 is less than 10, and that is true. You couldn't ever write it the other way around. 10 is less than x is less than 8, because if you cover up the x, it's not true. But in this case it is. And the same thing over here. If we cover up the x right here, we would be left with 3 is less than 5, which is true. So that tells us it's an okay way to write it. Okay, let's look at this next one. Here we have a whole compound inequality that is written with that shorthand. It says -3 is less than or equal to 1 minus 2x is less than or equal to 3. In other words, 1 minus 2x is in between 3 and -3. The way you need to think about this whenever you have this three-part thing where you have two inequality signs and you have something on both ends, just like with an equation, you add something to one side, you add it to the other. We're going to do the same thing here, but you have to do it to all three pieces. So anything you do to this piece here, you're going to do in the middle, and you're also going to do on the right. Our x is right here in the middle. We want to isolate it. We want to end up with just x in the middle. So I'm going to start by subtracting the 1, because if this was half of an equation, I would subtract 1. But instead of just doing it on either side of an equal sign, I'm going to be doing it on every side of those inequalities. So I get -4 less than or equal to. You never change your signs. If they start out as less than signs, you keep them less than. If they start out as less than or equal to, you keep them as less than or equal to. And then I get 3 minus 1, which is 2. Okay. Now, again, we're working on isolating the x. We have -2 times it, so we need to divide by -2. And so I get -4 divided by -2 is a +2. In the middle, they cancel out, so I just get x. And then 2 divided by -2 is a -1. Now, what did you notice that we did? We divided by a negative number. Do you remember at the beginning of this section, in the other video, we said if we multiply or divide by a negative number, what do we have to do? We have to turn our signs around. So this is the only time that you change your signs, is if you multiply or divide by a negative number, you have to turn them around. And so that's what we're doing here. We're changing those less than or equal to's to greater than or equal to. Now notice we didn't take the or equal to out. If you start with that, you keep that. But we do turn them around because we divided by a negative number. Now, it kind of bothers me here that we're starting with a big number and we're going small. It's kind of customary to start with the smallest and go to the biggest. So instead of leaving my answer this way, I'm going to start with the -1. And since I'm reading it backwards, instead of using greater than or equal to, I'm going to use less than or equal to, because I'm turning it all around. X is less than or equal to 2. So our answer is all of those numbers in between -1 and 2, including the -1 and the 2. So on a number line, it would look like this, because remember, sometimes we're asked to put our answers on a number line. Sometimes we're asked to just write them as an inequality. And then the third thing is sometimes we're asked to do them in set notation. So we'll do that as well. Since we are including the -1, it has the or equal to. I fill the circle in into the 2. And anytime you have this shorthand notation that writes this all as one piece with the x in the middle, we are talking about these numbers in between -1 and 2. Now the last way that you could write this is in interval notation. Our interval is this piece in the middle from -1 to 2. There's no infinity here. We're just blocked in between -1 and 2. So to write this as an interval, we're going to write our endpoints, -1 and 2. Since we are including them, you use square brackets. So anytime you're filling the circle in, or it says or equal to, block the square bracket. So these three things go together: the or equal to, the fill in the circle, and the square bracket. Let's go back up here to the 8 and less than x less than 10, because I forgot to do it in interval notation. So similar to this one down here, we're going to list our endpoints, 8 and 10. But this time, since these are just less than, they're not or equal to, I use round parentheses. So again, the three things that go together, the less than without the equal to, is open circles and round. So do you see the difference between this problem and that problem? Because this one has the or equal to. Okay, let's look at the very last section here. In this section, instead of using and, we're going to use or. And whenever you have, and this is called a disjunction, so a disjunction is a compound inequality using the word or, the solutions are all of the points that make either one of them true. So if it makes the first one true or it makes the second one true, it's going to be included in our answer. So for the ands, we looked for the overlap. For the ors, we're going to include everything that makes either one of them true. So it's like adding the two pieces together. So here we have a compound inequality. Our first inequality is 3x minus 1 is less than 5. Those are joined with an or to 3x minus 1 is greater than 5. Let me erase that. Circle got a little out of hand there and covered up part of my problem. So just like we did before, we're going to treat our two sides separately. We're going to solve this half, then solve that half, and then we'll put the two together. So my x is right here. I want to isolate that, so I need to add 1 to both sides. And I get 3x. These ones cancel out. -5 plus 1 is -4. And then divide by 3. Okay, I paused it there for a second while I wrote all that out. So I divided by the 3. And so that gave me x is less than -4/3. Since we're going to be putting these on a number line, I just rewrote that as a mixed number, -1 1/3. Okay, now let's look at the other side. And I'm just going to do this when I'm going to pause and write it all out. So you can do the same, and then you can check to see that you have it correct. Okay, I didn't show the steps over here on the right. If you didn't get x is greater than 2, you can pause it, check this, and see where you're different than what I came up with. And then once you get your two halves done, you're going to count them again with the or, to get the final answer of x is less than -1 1/3 or x is greater than 2. Now let's write it our two other ways. Let's put it on a number line. We have two pieces. We have x is less than -1 1/3, so that's a little bit less than -1. X is greater than 2 is this piece out here. Open circles, because I'm not including them, but since this is joined by or, we're not looking for the overlap. We're going to bring all of that down, and that is our solution. Now, interval notation, this starts at -infinity and goes up to -1, so I'm using round brackets for those two pieces. I'm going to combine that with, and we use this symbol, which means unity. And then I'm describing this path over here, which is starting at 2 and going out to infinity. So there is our interval notation.